it is clearly seen from the data in table below. Liquid pair, water and benzene, solute benzoic acid and succinic acid, and partition coefficient at 293 Kelvin, temperature 0.0274 and 0.096. Nature of liquid pair. A given solute has partition coefficient in different liquid pairs as shown in the table below. Liquid pair solute and partition coefficient at 293 Kelvin temperature. Water and ether has solute succinic acid and partition coefficient 5.423, and liquid pair water and benzene solute succinic acid partition coefficient 0.096. Third, temperature. The solubility of a solute in a particular solvent changes with temperature. As the temperature is changed, the solubility of a solute in a given liquid pair also changes. Therefore, the partition coefficient also changes with temperature. The change in value of partition coefficient for 1 degree rise in temperature is known as temperature coefficient. However, the value of temperature coefficient is generally small. Table below shows value temperature coefficient for some system. System acetic acid in water and ether, temperature coefficient 0.0064. System succinic acid in water and ether, temperature coefficient 0.55. Next, experimental verification of distribution law. Solutions of iodine in carbon tetrachloride of different concentrations are shaken with water taken in different bottles. These are allowed to stand undistributed till the two layers separate out. A known volume of CCl4 layer and aqueous layer is pipetted out and titrated against standard sodium thiosulfate solution, and the concentration of iodine is determined. The following results from the distribution of I2 between CCl4 and water show the constancy of ratio of concentration in each layer, hence prove the validity of distribution law. Next, condition for validity of distribution law or limitations of nullness distribution law. The distribution law in its simple form, that is K is equal to C1 upon C2, does not hold under all conditions. Some limitations and the condition under which the law is applicable are as follows. First, temperature should be kept constant. The solubility of a solute in both the liquids changes with change in temperature. This may result in change in concentration in both the solvents.